Unit 7, Lesson 1, Parameters and Return Explore. Students, you will be able to use appropriate vocabulary to describe parameters and return values, and you'll also be able to remove specifics from a function so that it can be used in a variety of situations. Now, up to this point, you've learned the basics of programming. What is a variable, conditionals, functions, lists, loops, and traversals. As you continue to grow in your programming skills, you will start to notice ways that you can organize your code so that it's easier to work with. That's what this whole unit is about, to make your code easier to work with. So first, think about, why would you want to make your code easier to work with or easier to read? What are the benefits? Pause and jot those notes down in your notebook, your journal, whatever you want to call it. Okay, so why would we want to make it easier to work with or read? Because we're not writing code just for a computer. We're also writing for the humans, ourselves and others, who will need to understand the code. Better organization can help others to quickly understand our code so they can help debug or build upon and modify the code. And by the way, it can also help you later on. If you've written some code and it's working, a year or two later, you decide you want to modify it, add something onto it, make it different, build upon it. You would be surprised how quickly you forget what's where. Having comments, it's just your way of taking notes and remembering. Now, our activity today. You should have, and it doesn't have to be sticky notes. Anytime this thing says sticky notes, you can also have just small pieces of paper. Usually 2 different colors helps, but that's okay if you don't. And some regular size. So you want 2 different size pieces of paper, and then an envelope or 2. You also will always need a writing utensil, okay? And by the way, pause the video here and go get that stuff if you need it, if you're not in an actual classroom. Now that you're back, let's pretend that I want to make a cake. I need to decide how many tiers the cake will have and what flavor the cake will be. I have decided to make a 3-tiered lemon cake. So I want to make a cake. I want it to have 3 tiers, and I want the flavor to be lemon. So I'm going to say make cake 3 lemon. Well, make cake is a call to a function. If I flip over an envelope and open it up, there's a recipe inside, or there will be a recipe inside, okay? You put your recipe inside. And this recipe is going to tell me how to make the cake that I have specified. So this recipe is going to take this information, plug it in, and tell me how to make my cake. How's it going to do this? Well, I'm going to replace tiers with 3 and flavor with lemon every time those words show up in the recipe. But notice this recipe is pretty general, so I could use it to make a lot of different types and sizes of cakes. So inside of make cake, the recipe says repeat tiers. Well, that's 3. So I'm going to repeat 3 times. Bake a lemon cake, ice the cake. And I've got to do this 3 times. So I've got to bake a lemon cake and then ice it. Bake another one, ice it. Bake another one, ice it. So I'm going to do it 3 times. Then I will assemble 3 tier layers into one cake. And then I'll finally put it in a box. Now, let's make our cake. Each time I come across tiers or flavor, I'm going to replace that word with the appropriate value that was passed to the function. Once I'm done, I will have baked my 3-layer lemon cake. So make cake 3 lemon. Repeat 3 times. Bake a lemon cake, ice the cake. Okay, so I'm going to bake a cake, ice it. There's 1. Bake a cake, ice it. There's 2. I'm going to bake a cake and ice it. There's my 3rd time. Okay, ice it a little better. Perfectionist, right? So I've done that 3 times. Now I'm going to assemble how many? Well, I'm going to need to assemble, oops, we're going to clone this guy, clone, 3 tiers. Okay, so I'm going to assemble 3 tiers into 1 layer cake. So I'm going to take this guy, and I'm going to put them on to this guy. And then I'm going to take both of these and put them here so that I now have my 3-layer cake. And then I'm going to take this whole thing, so I've assembled it, and now notice I need to put it in the box. So I'm going to put this in my box. I'm going to pretend like we just, oops, put it in the box. Woo-hoo. Okay, and then we shut our box, and our cake is in our box. Okay? Now, what you want to notice is that we have a function, and it takes arguments and parameters. Okay? It's a function. It should look familiar. You've done functions already. But this function has parameters. Parameters are used as placeholders for values that will be passed through the function. An argument is something that is given to the function. So make cake gets the argument 3 and puts it into the parameter tiers, and lemon goes into flavor. An argument is a value passed to a parameter. A parameter is a variable in a function definition, and it's used as a placeholder for values that will be passed through the function. Now, what if I want a 4-layer chocolate cake? Okay, so I want a 4-layer chocolate cake. What would it look like? Well, I would say make cake or chocolate. What would my cake actually look like? 4 layers with chocolate icing. Now, it's time to create your own function with parameters. What I want you to do is complete challenge 1 in your activity guide. And this is all going to depend, I'm making this video so that when we're back in school for real, hopefully later this year, maybe not until next year, whatever, I would have you work with a partner. In virtual world, I'll put you into a breakout room with a partner. But before I put you into a breakout room with a partner, what I want you to do is right now, okay, you're going to create your own function envelopes, and you're going to write a simple function that uses parameters, which can be used to draw a house. When you're finished building your function envelopes, as a partner will test out the code and draw the house on a separate piece of paper and see if it's what you intended. Okay, so grab that activity guide. Either I've sent it to you, it's if we're in real school, I'm handing it to you. If you're doing this online all by yourself or in virtual school, please make sure that from the Canvas course or from the code.org Unit 7 Lesson 1, you've downloaded your activity guide. And then proceed to do challenge 1. You should take about 10 minutes, probably a little less than 10 minutes to actually complete your code. Remember, this isn't computer code, this is pseudocode, just like the Make a Cake. Go ahead and pause the video and create your code to make your house. You're back. Now, if you missed class and you're doing this all by yourself, you might ask a sibling or a parent to just see if they could make your house. If not, that's okay. We'll continue. Let's look at another function, this time one that calculates the cost of making our cake. We have cost cake, and it needs how many tiers? So 3, and it needs the flavor, lemon. So we want to know the cost of a cake that's 3 tiers and is lemon. Remember, we have our arguments, and these are our parameters. Now, let's open the envelope and see how much our cake costs. So, our cake cost function creates 2 new local variables. They're local because I only want to use them inside the function. Outside the function, they don't mean anything. So I've got a flavor cost and the total. Then it says if flavor equals chocolate, the flavor cost is set to 5. If flavor cost equals lemon, the flavor cost is set to 3. If flavor cost is vanilla, flavor cost is equal to 3 or set to 3. Then the total is equal to the flavor cost multiplied by the number of tiers. And then we return the total. What? Return? Return where? I guess I'm returning total, which is going to be a value, but where is it going? Well, oops. The total gets returned to where it came from. But before we talk about that, let's see what total equals, okay? So we've got cake cost, 3 tiers, lemon. So if flavor, which is lemon, is chocolate, nope, it's not, so I'm going to skip over. If flavor equals lemon, flavor cost is set to 4. Great, flavor cost is 4. If flavor, lemon equals vanilla, flavor cost is set to 3. Nope, it's still 4. So now what am I going to do? I am going to multiply my flavor cost. Oops. My flavor cost, which is, if I can get my pen to work here, my flavor cost, which I know is 4 by 3, so that's going to equal 12. And then I'm going to return the value that's in total, which is 12. So flavor cost is 4, total is 12. Now remember that when my function goes away, so do my local variables. So they go poof, goodbye. But I'm returning total. So what does it mean to return total? A return does 2 things. It stops the flow of the function. If a return is inside a conditional or a loop, if that condition is met, the function ends then and there, boom, all gone. And it returns a value to the place where the function was called. So it's going to send that value back. So we've called the cost cake function. It has a return value of 12. But what happens when that value gets returned? How does it stored? Well, let's go back to our variable baggies. A function, sorry about that. A function return value can be stored in a variable. But if you don't store it in a variable, you don't print it out, it gets returned, but it kind of gets thrown up in the air and then lost. So we have cake calculator, and it's going to have 12. You called it, then it's returning 12. So you can set it as var cake calculator is set to cake cost 3, lemon. Here's your cake calculator variable baggie, and you're going to pass it this information, and it's going to return to you 12. It's okay if it's a little confusing. You get to play with this in Code Studio in the next lesson. For now, notice that the statement is set up. A variable is set up with the name cake calculator. This gets the value that is returned from the function cake cost, which has 2 arguments, 3 and lemon, which were passed through the parameters. After the function is evaluated, cake calculator now stores the value 12. We could also print to the console, like so. Console.log, cake cost, and then concatenate it with the actual cost of the cake. So you get cake cost 12. Okay, now we're going to continue on with the activity, and we're going to create a cost calculator function for the building of the house that you created in your function earlier. All right, so complete challenge 2 on your activity guide, and when you're done, or after about 8 minutes or so, I'm going to partner you up and send you off so that you can try each other's, make sure that it works. So this is going to be your house calculator, similar to cake calculator. Go ahead and pause your video and do this now. Okay? As a wrap up, and again, if you're in class, I would be helping you with it. I'd be answering questions, popping in and out of breakout rooms, etc. In general, the takeaways. Functions with parameters and return values help us simplify our code. Functions can only return one value at a time. A function can have no parameters and no return values. It could have parameters but no return values. It could have return values but no parameters. And it could have parameters and return values. A parameter is a variable in a function definition used as a placeholder for values that will be passed through the function. An argument is the actual value that's passed. And return is used to return the flow of control to the point where the procedure, known as a function, was called, and to return the value of the expression. Now, why would we use parameters? Parameters allow us to create a general function, and the parameters allow us to make it more specific. You can bake a cake, but there are so many different kinds of cakes and so many different sizes of cakes. By using parameters, we're able to specify specifically what type of cake. But once you know what kind of cake, they all go through the same process of combining ingredients and baking and icing. So you've taken something that's general and specified it. It's more layers of abstraction, which we're going to talk about in the next lesson.